Welcome to this session. My name is Samuel. Today, I'm going to talk about matrices and transformation. We are going to learn step-by-step process on how to create a matrix or simulation of transformation. And we are going to use GeoGebra. I'm also going to give a chance to students to use inquiry method to achieve this particular objective of the day. Now, what is these matrices and transformation? Before we start, I'd like to inform you that I'm on the process of coming up with a website, that is Subbad Online website, which will be active very soon. So let's embark on the topic of the day. So matrices and transformation. Our objective today is to be able to use matrix simulation in GeoGebra to determine and describe various transformation matrices. And in this case, we are going to have the following rationale. Matrices and transformation is very rich in application in real-life situation. That's why it is very important. Also, it is very much applicable in high-level careers like architecture. Very useful. Also, not forgetting that it is part of the curriculum in various systems of education that we have in the world. Now, what are the conceptual issues that we have in matrices and transformation? Now, look at this building here. You can see we have congruent figures. These windows are very congruent. You can see these pillars are acting like mirrors, the reflection lines, the mirror lines, you can see. You can see also congruence on these particular parts of the building, and you can see a sort of translation from one point to another and translations on this other side. So transformation is very key in real life situation. We can also look at the wheel hub. You can see rotation symmetry that is playing part here. You can see also congruence here and rotation symmetry at the same time. At the same time also here, rotation symmetry and congruency. Also, in knitting industry, you can see the patterns, you can see reflection, you can see translation, all playing part here, all playing part here. That is how useful this transformation is. Also remember that after you watch the video, share and subscribe. Kindly do that. So where are we going to start today? In today's session, we are going to deal with the following areas. That is these types of transformation matrices. We're going to deal with identity matrix. We're going to deal with reflection along x-axis, reflection along y-axis, reflection in the line y is equals to x, reflection in the line y is equal y plus x is equals to 0, or y is equals to negative x. We are also going to talk about rotations about the origin, the description about the origin. We are going also to talk about half turn about the origin and also 3/4 turn about the origin. These are the areas that we are going to deal with. So for us to manage that, we are going to use GeoGebra, and we are going to go through the process step by step. Step number 1, when you want to use GeoGebra in simulation, is to create sliders. So this is the slider, that is, slider. So create 4 sliders to represent the 4 elements in a matrix. So slider number 1, move from maximum -1 to minimum, that is minimum -1 to maximum 1, and increment is 1. So you create matrix 1. Then you come to matrix B, do the same because we just want to deal with the area that we have restricted ourselves in. So that is increment of 1. So create the 4 sliders, and then slider number 3, you do the same. Slider number 3, then increment of 1, and then slider number 4, which is D. Just the same thing, and then you're done. So you have created now the 4 sliders. These sliders are very important for when we shall do simulation, okay? Because as you can see, these sliders, the sliders are moving from 1 is maximum, then 0, then -1. So they are moving increment of 1. That's why the increment works here. So you can also put increments in terms of decimals, but in this case we want to use 1. So that is step 1. Step 2 here, you create the coordinates. So create the coordinates. This is how you create the coordinates for a unit square. So we need to create coordinates for the unit square. That is A. So A has been shown there. Create B for the unit square. So B will be here. It will be 1, 0. 1, 0. Create B. Sorry. So you have to write is equals to, so that it responds. So then C, so C is equals to, so up here that is 1, 1. That is 1, 1. And then finally D, it will be 0, 1. So it will be 0, 1. So there you have, sorry, D is equal to, so don't forget the equal sign. So D is equals to 0, 1. So that is what you have. And then you use the polygon and then join A, B, C, D. So we have the polygon A, B, C, D, which is okay. Now, you can see that the unit square is good, but very small. So we can use zoom. Just zoom it out. Zoom, zoom, zoom in, zoom. I think that one is big enough. It's a bit bigger. Yeah, that's okay. And reposition. Yeah, so we have our polygon Q1. You can see Q1 polygon ABCD, which we have created, and we have our sliders. So these sliders cannot affect this polygon, so we have to use other commands. So we are going to create the matrix now, which will involve these 4 elements here, A, B, C, D. So how do we create matrices? Matrix. So one thing that you have to do, you have to just say, we want to create matrix M is equals to, so you have to use these curly brackets. Use those brackets. So the first one is AB, and then come to the second one, just put a comma there, and then open the second one. Then we have CD, CD there. Okay, so we have ABCD. So enter. As you enter, you can see that we have created a matrix A, C, B, D here. The matrix is here. So this matrix now, because of A, B, C, and D here, can be affected now. Will work with our simulation here. So you can see that as you change A to -1, you can see it is changing here. Even C, if you change it to 0, C now is becoming 0. So it is working on this one. Okay. So after that, we want now this matrix to work on this polygon. So the next step that you do now is to apply. So we want to apply, what do you want to apply? We want to apply the matrix. It will come, it will pop up. So we want to apply the matrix. The matrix is M, so just M there. And what did we see is our polygon, Q1. You saw the Q1 up there. So when you do that, it starts affecting the transformation here. You can see the first transformation here. Okay, so now if you look at this transformation, as you go along these trying to change these figures as you simulate, you can see there is impact. There is an impact. There is some transformation that is happening here. But we can say that we know that it is sufficient this way, but we can make it even much better by bringing the matrix on this particular page here. This matrix here. This matrix can come here. Then how do we bring it here so that it becomes more visible? So you have to come to ABC there. Then you click there. You activate LaTeX. Then from here, come to LaTeX first and pick your matrix. So now when you have picked that one, this is what you have to do. Even before you do that, you can see this one, we want to represent our M. So bring our M here at the beginning. Just say M is equals to, first is equals to this. So the values that you're going to use are not these ones. We are going to use the values from the object properties here, okay? These values that are here. So for A here, we are not going to use that A, but we will use the A that is in the object property here, A. And you can see it is highlighted. Then just move to steps, and then we have B. So you come to B. So we have dealt with A and B. So we are dealing, that is A and B. So we have to come to C and D. So then we have C there. So we have to come back here and find where C is, and then just 2 steps there, then D. Then when you do that, then you can get your matrix coming here. Okay. So when you have 1, 1, 1, 1, remember we had something like that, 1, 1, 1, 1, you can see. So we can now manipulate anything that we want, you know, from this particular simulation here. So we can also make this one, you can color it, we can make it color there, we can change, we can make it bold, we can change it to medium. It becomes better, you know, so students can easily see. Students can easily see from the distance. Now here we have the following. So we have A, B, C, D. Now, depending on how you have set your activity, you'd like the students to discover that when the students come to, for instance, if we come to point B, 1, 0, and then C is 0, 0, 1, you see this one is an identity matrix. So what will be the discovery? Students will discover that D remains at the same point, object and image, A the same, B the same, and C the same. So this kind of transformation is called an identity. So identity, which means there is no change, and it is congruent, you know. That is how the students will now try to discuss the aspects of identity matrix. Okay, so that's one. Through inquiry also, the students, through the demonstration of the teacher, depending on the resources that you have, if you have enough resources, students can do them individually or in groups, or the teacher can demonstrate, using the projector to the students also to discover various transformations. If, for instance, we have A is 1, then we have D, for instance, if I bring it here, you can see there is another transformation that has been formed. And this one now you leave the students to discover. B remains on the same position, A remains on the same position, but C has come to this point and D has come to this point. And the image formed is congruent to the object, you know. Then the discovery here is that this is a reflection along the x-axis, you know. The students can do this one in various ways, you know, along the x-axis. So the description is that this is a reflection along the line y is equals to 0 or along the x-axis. That is the description, full description of the transformation. We can also talk about some other kind of transformation. If you have this type of transformation, I want you to tell me what really happens. So let me say 0. We have 0, negative 1, and then 1, and then 0 here. So what has happened here? So we have 0, yes. So what has happened? You know, so you can see B came to this point. You can see A remained here. You can see this is B came here. D that was here now has come here. A student needs to discover that this one cannot be a reflection, you know, because you can see how the object and the image are placed. Then it becomes a rotation. You can see from this point, this is 90 degrees, and this one came to this particular point. You see, a teacher can use various ways of showing rotation. You can use even curves. You can use even certain curves to show that it is a rotation. You can see, you know, you can see how it goes round. You can see how you can really demonstrate rotation. It is a rotation. It is a rotation. You see, from B to B, and then D moved from here to D prime. That is here. It is a rotation. But how do you describe it? It is a rotation about the origin, which is 0, 0. That is a full description. Don't just say it is a rotation. You have to say it is a rotation about a point 0, 0, or the origin in this particular case. That B was in this position 1, 0, now has come to a position 0, 1. Okay, that is the full description. We can do one more. If we can do, for instance, maybe 0, 1, we can say let be 0, 1, 1, 0. This is another interesting one. What can you say about it? 0, 1, then 1, 0. D has come here. D was here, has come here. B was here, came here. A remains, C remains, the same spot. Okay? So when you look at all these, student can use even the construction means of trying to find what kind of a transformation that really happened. So when you look at all these, you find that this for B to X to interchange with the D, then there is a reflection. So what type of a reflection is this? Then it is a reflection along the line Y is equals to X. So then it can be easier for the students to see that this is the kind of transformation that has happened. So B and D are interchanging. C did not change and A did not change. So it is easier for the students to discover on their own through inquiry-based method. And this one will help the learners to concretize all this information and to concretize the concept easily that they are learning during the day. So if teachers, we can allow the learners to go through this process of inquiry, then we make learning more useful, you know, in their lives, and we make the students to be motivated to come to your class, you know, and this one will make the success and performance in mathematics for each and every student in your class. Therefore, I hope this video has helped you, and in the next video, I'm going to, as I committed myself, to produce a video which will deal with enlargement, stretch, and shares. Remember, as you complete watching this video, just share and subscribe and like it. Thank you very much. Let us meet in the next video.